Hi, and welcome to today's webinar. It's titled A Poka-Yoke Primer, Mistake Proofing and Error Reduction. I'm Mark Graban, your host today. I'm a senior advisor with KaiNexus, and I'm really happy to be joined by our presenter today, John Grout. He's a professor from Berry College. You'll learn more about him in just a minute. So welcome, and thanks to everybody for being here today. Before we introduce John, next slide, please. If this is your first time attending one of our KaiNexus Continuous Improvement webinars, again, I want to welcome you to our sessions. We are a software company, a technology provider whose passion and mission is to spread continuous improvement. So if you'd like to learn more about how our platform and solutions can help you, please visit our website at kainexus.com, or you can scan that QR code. So now I'll introduce our esteemed presenter today, John Grout. He is the David C. Garrett Jr. Professor. He's the former dean and award-winning teacher in the Campbell School of Business at Berry College. Dr. Grout has researched lean supply chain management and mistake proofing, aka Poka-Yoke, extensively and has published numerous articles on the topic. John was awarded the Shingo Prize for his paper titled The Human Side of Mistake Proofing, co-authored with Douglas Stewart. John has also consulted with a large variety of firms to mistake-proof their processes, something that's so important, regardless of whether it's manufacturing or healthcare or software or what have you. So with that, John, thank you for being here. I will turn things over to you.
Thanks, Mark. It's a pleasure to be here. And so we'll get started on the presentation. Our objectives today are to build an understanding and awareness of mistake proofing. And the format that Mark mentioned is something called Pachachka, although I think that if you sound that out, I'm not sure how it turns out to be Pachachka, but that's how Daniel Pink said it on a video, and so I'm going to copy him. It's 20 slides, and each slide is set to auto-advance after 20 seconds. So if I get behind, there may be a little lack of synchronization there. I'm going to talk about what mistake proofing is in one Pachachka presentation, and then kind of how to, why people err and how do we eliminate errors in the second Pachachka presentation. And so, I'll have a little sort of intermission, if you will, in between the two presentations where I'm going to talk about some examples. And at the end, I will kind of recap and sum up at the end and talk about kind of next steps of implementation. And because I'm a professor, I might even assign a little homework. So, that's our agenda for today, 2 Pachachkas. And the very end, we'll have some question and answer. And so feel free to hit the Q&A button to submit your questions, and happy to try and answer those. So first of all, let's talk about Pachachka. It was originally designed by Astrid Klein and Mark Ditham. They were 2 architects in Tokyo, and apparently when architects get together to make presentations, they go on and on and on, and they wanted to figure out a way to kind of trim things back and make things exciting. And so they said, look, you get 20 slides. Each slide has to show for exactly 20 seconds. That means every presentation will be 6 minutes and 40 seconds. And that's it. And we'll get through things a lot quicker. And so in my case, I think that works out to about 75% of the slides are presented in about 22% of the time. And so I'm hoping that won't feel like it's a drinking out of a fire hose, but that's kind of the direction we're going to go with this. And so with that in mind, I think we're ready for our first Pachachka presentation. So buckle up and let's see if we can get this done. And so here we go. Here are the Japanese katakana characters for Poka-Yoke. The Japanese have a different word for everything, so I typically use the English translation, which is mistake proofing. It is accomplished by making small design changes to processes or products to prevent non-conformances or errors. Sometimes mistake mistake proofing focuses on detecting errors. Do you see the orange dots around the nuts? Those are evidence that the nuts are properly tightened. If you look at the bottom second from the left, you'll see that it is not properly tightened. Other times, mistake proofing means preventing errors. This table saw prevents worker injuries by actually sensing human flesh and taking evasive action. The next slide is a video clip. The hot dog in the clip represents a human finger. Watch carefully, it moves fast. The table saw prevents worker injuries by actually sensing human flesh. The blade is electrically charged and monitored with a signal processor. And so the result is a $70 single-use saw stop module and a $75 saw blade that are completely non-functional, but a bleeding but fully functional thumb. Their top-of-the-line saws cost $300 to $700 more than a typical competitor, so you have to decide how much your finger is worth. Sometimes mistake proofing can mean fail-safing. The error occurs, goes undetected, but at least the influence of mistakes is minimized. This gasoline hose is designed to break away in a controlled, damage-minimizing kind of a way. Chase and Stewart considered how mistake proofing could be applied to services. Since customers are a critical input to service processes, their actions need to be mistake-proof too. Here is a go, no-go gauge for patrons of the mall play area. And here's another example of customer mistake proofing. Do you see it? The swing arm at the front of the bus forces children to walk far enough forward to be in the field of vision of the driver. No signal processors here, no electronic child detectors, just a simple solution that works well enough. Noted psychologist Donald Norman recommends putting knowledge in the world rather than knowledge in the head. Here's an example of putting knowledge in the world. For this Toyota engine, which dipstick is the oil and which is the transmission? Transmission is a T and oil is an O. Putting knowledge in the world can communicate all kinds of things. It can communicate when something is worn out, what type of object it is, what is the temperature, how to get somewhere. Other times the message is simple: hide because there's a prisoner who has a knife. Speaking of putting knowledge in the world, mistake proofing can be used to avoid all sorts of undesirable outcomes, like falling into the toilet in the middle of the night. When the seat is up, the light is red. Down is green. Ironically, failure can be a good thing in mistake proofing. Elisha Otis did not invent the elevator. He invented the elevator brake. He created a system to get elevators stuck between floors when the rope breaks. Being stuck between floors is definitely a failure, but Otis thought being stuck between floors clearly beats falling to your death. Prior to Elisha Otis's 1853 invention of the elevator brake, elevators were dumbwaiters for furniture. People took the stairs. Few buildings were taller than 5 stories. His mistake-proofing device facilitated our modern skyline. In this photo, the star-shaped wheel can only turn if the container below are right side up. Otherwise, the wheel jams against the bottom of the container and stops the process. The machine is designed to jam, to fail when defects occur. Here's another example of a designed stoppage inside a copy machine. The designer wanted to ensure the blue lever is closed before the door is shut. A special bump inside the door stops it from closing until the lever is in the correct position. As a general rule, if you can't take a picture of it, it's not mistake proofing. The exception is high-tech equipment or devices where software can create mistake proofing outcomes that cannot be photographed. This phone stops audio output anytime the Bluetooth speaker is turned off. you don't miss any of your song or your audiobook. Although Shigeo Shingo coined the term Poka-Yoke, he did not invent it. This poison bottle from the 1800s is proof. It is color-coded and spiked to alert pharmacists through visual and tactile means. There are lots more medicines today than in the 1800s, so computerized medication dispensing often is used to reduce errors. However, nurses still need to pay attention to their work. At left, red floor tiles sequester the nurse from interruptions during this critical task. At right, the other floor markings communicate to healthcare workers. Creating simplicity is not a simple task. Elegantly eliminating errors is challenging. Sometimes you mistake-proof an error in one place and it just shifts somewhere else. However, with some creativity, you can mistake-proof all kinds of processes, even ones that you would think defy process control. A Dutch firm installed urinals etched with the image of a fly on the porcelain at the JFK International Terminal. It cut spillage by 80%. Just think about collecting that data on your control charts. Well, time's up. That's it. 20 slides, 20 seconds. So I'm going to take a breather and let's talk about some examples for a minute. In Shigeo Shingo's book, his original kind of list of common mistake-proofing devices were these. He liked guide pins, so pins that you use to kind of locate parts as you put them on the machine. Blinking lights and alarms, I think, are pretty common fare among a lot of factories out there. Limit switches to detect if the part is present or absent is also a very common kind of a thing, as are proximity switches and counters, and checklists. Now, I have mixed feelings about checklists. A lot of times people will do all of the work and then check the checklist, and I'm not sure that's the most effective way to do it. I think it's really good to think carefully about whether the checklist can be embedded in the actual process. Hello Windows used this in their window assembly process. They had hardware, and they actually had a little board with little holes, and you would put all of the hardware down into the holes in order to make sure they were there. It was backlit so that it would light any hole that was not filled, and that helped them to reduce errors. That's a form of checklist, I suppose. If you're interested in checklists, Atul Gawande has written a book called The Checklist Manifesto. I recommend it to you as a way to think more about checklists. And if you look through the world at large, you'll start to see lots of mistake-proofing examples all over the place. Now, this one's a little out of date. It's a 3.5-inch disc that can only be put in the machine one way, but I'm going to continue to claim it as a reasonable example until they change the icon with which to save documents. So you see up in the upper left corner there, the save icon is still a 3.5-inch diskette. So I'm going to use that as an example. And with 3.5-inch diskettes, there are, I think, 8 different ways that you can orient it to try and put it in there, but only one of them will allow the diskette to go in. On another front, in the automotive front, I think that the auto companies have all sort of realized that if they don't attach the filler cap, the gas cap to the filler neck, that we will leave them behind at gas stations on a regular basis. And so whether you are gas or electric, it's pretty clear that in both cases, they're going to make sure that the caps go with you. Another example is lawnmowers. They have a second handle that you have to pull back in order to start it. That way your hands are accounted for. So if you want to cut off your fingers, you have to work much harder to do it, and prevents those types of errors. in this upper right corner, we have a pick-to-light bin system that is an off-the-shelf system you can buy, where little lights will light up to show you which bin you should pick product from. And if you put your hand in any of the other bins, an alarm will sound and you will have to reset the machine. You can link it to an Ethernet and download custom pick lists. And so I think it's a pretty clever kind of an example. One of my favorites is when you're painting ceilings, they're already white normally. And so when you're painting them, putting white paint on top of white paint, it's hard to tell where it is. And so Glidden has brought out this product that's pink. And so as you roll it on, you make everything pink and then it dries white. And so a fantastic example of mistake proofing, helping you to get full coverage on your ceiling paint. I was at a gas station in my neighborhood, and the truck that was filling up the gas station's tanks had these little plastic devices on the lug nuts on the front wheel of the truck. And as you can see, they make a very distinct geometric pattern. And if one of the lug nuts is loose, of course, the pattern will be disrupted and you'll be able to visually see it much more rapidly and take preventive action. I also have to tell you that my wife doesn't like when I drive by Braille, but the little rumble strips on the side of the road serve an important function to let you know if you're straying and not paying attention the way you should. And so in that case, in some sense, the error is already in progress, but at least you detect it quickly enough that it keeps you from doing something more serious. In the lower right corner there, we have a very standard kind of manhole cover. You wouldn't think that there's much mistake proofing going on there with that old technology, but the fact that it's round means that it can't fall down in and hit workers below. Sometimes I will see rectangular ones, and my thought is that those can be turned in an orientation where they will fall down and hit a worker below, and that's well to be avoided. My final example for you today comes out of Lockheed Martin. And so I did some presentations for them and some training for them long ago, and went back a few years ago, and it's still in use. But at the bottom here is something that they call a hog trough. Good Southern descriptor for that. The hog trough is designed to allow workers to transfer wiring harnesses from very expansive, complicated wire harness boards out to C-130 cargo aircraft, and to load it onto that aircraft without disrupting any of the connectors. And originally, they would take these wire harnesses, take them off the board, coil them up, take them out to the plane, and then uncoil them. And the little connectors on the ends would get caught on each other and loose connections would result. And so their solution was to build this thing called a hog trough. And essentially what you do is you take the wiring harness off of the wiring harness board, put it in the hog trough, carry the hog trough out into the plane, you walk up the back ramp into the plane, screw it in place, and that way all of the components are poking out right where they should be. Everything gets plugged in. And, a mark of really good mistake proofing is where it reduces the error and it speeds up the process. And this is one of those cases where they drove a lot of troubleshooting out of the process. They drove a lot of kind of connection time of unrolling it and so forth. And so there are lots of really interesting examples. If you watch for them in real life, you will find them. And you can make a big difference in the way your company performs by thinking about the design of the process and trying to create mistake-proofing devices for that process. So I think we're ready for another Pachachka. I think I've caught my breath just a little. And so I think we're ready to go here. Time is looking like it's going to be well within the specifications. So let's go. Here we're going to do another 20 slides in 20 seconds. So I'd like to introduce you to James Reason, a famous psychologist. He has spent a career studying why human beings make mistakes. He observes that there are two parts to any action: the intent, what you decide should be done, and the execution, the actual doing of what was intended. Here, the sign is intended to help visitors find their way, but as you can see, the execution is faulty. He has also observed that we act differently in different circumstances. Reason finds that when circumstances are very familiar to us, we do not deliberate too much about intent. We know what to do automatically and just do it. Other times we recognize the circumstances and use a rule based on our past experience to know what to do. When we encounter something truly unusual, then we have to think about what we do. Have you ever driven through a traffic light and not remembered whether it was green or not? That is something called a skill-based action. And in that case, no deliberation or decision-making is really required. We hardly think about it at all. But what if you come to a light that is blinking red? That's unusual. Do you know what to do? Sure. The little booklet you studied to get your driver's license said that if it was a blinking light, you treat it like a stop sign. You recognize that there's a rule and that it applies to this situation, and you use that rule. That's rule-based action. Now, what if you come to a light that turns red just as you're approaching? You're in the middle lane and plan to go straight ahead. You wait for several minutes and nothing happens. What do you do then? The situation calls for knowledge-based action and deliberation about what to do. You might start thinking about how this will warp your plans for the day. You may start thinking about a right turn and an alternate route. You may look for police officers for help, or, if they're going to give you a ticket when you run that red light. In any case, you're going to need to think hard about what to do, and there is probably not a correct answer that is known in advance. And this is a key point. If the correct answer is not known in advance, you probably cannot use mistake proofing. Mistake proofing does not work for knowledge-based errors. If the error occurs in a rule-based action, then mistake proofing may work well, but other prevention strategies may also be needed. You should attack your problem from as many different angles as you can. If the error that occurs is a skill-based action, then mistake proofing is exactly the right tool for the job. What's next in designing a good mistake proofing device is to, 1, make sure you understand the problem, and 2, start brainstorming about solutions. 3, learn quickly which ideas don't work. To understand a problem, you need to know the root cause. A root cause is a cause that is within our control and would change the outcome of what we want. Also be careful, not all root causes are actions, some are conditions. The ignition source of a fire is only one of the causes of the fire. Causes also come in a continuum. One leads to the next. Toyota recommends asking why 5 times. An injury was caused by a fall, which was caused by a wet surface, which was caused by a leaky valve. Why did it leak? Because it was not maintained properly. Could you ask why the valve was not maintained properly? Sure. So 5 is not a magic number. You can keep going, but when should you stop? Stop when the answer is, I don't know, or I don't care. Why did he fall? Gravity. Why is there gravity? I don't know. You can stop. You don't need to go further. Once you understand the root cause, you should start looking for ways to mistake-proof the problem by preventing the cause from recurring. Before you act, you should come up with at least 7 ideas. Why 7? Once again, not a magic number, but it will stretch your imagination, and your first idea may not be your best idea. Here's a new word, try-storming. It's a mix of brainstorming and trying things out rapidly. In this photo, a group is trying a new assembly line layout with cardboard boxes, tape, and odds and ends. If something is not going to work, we want to find out as quickly and cheaply as we can. If you want to learn more about try-storming and the success that can result, I encourage you to Google Boeing's Moonshine Shop. These moonshine shops are groups of talented tinkerers with low supervision and high performance who make great process improvements at extremely low cost. Here's an example of the moonshine process. They try-storm or mock up lots of ideas. They discard some ideas and consolidate others. Then they refine their solutions until they have a polished, finished product. The particular tool dropped from 22 pounds to 2.5 pounds, and the installation time dropped from 30 seconds to 2 seconds. One of the moonshine rules is to get out of Kansas, which means leave the work area and look for ideas out in the world. Here's an example where seeing a hay elevator on a farm resulted in a great idea for loading seats onto 757 airliners. Here's the finished airline seat elevator. It cut the installation time for a full set of seats from 12 hours down to 2 hours. They also freed up the overhead crane, normally a bottleneck, to do other work. Out-of-pocket cost, about $2,000, and a little labor cost. So here's a quick summary. Use mistake proofing for rule-based and skill-based errors, but not for knowledge-based errors. Find the root cause, try-storm, and fail early and often in order to succeed faster. Well, there you go again. 20 slides, 20 seconds. Thanks for your attention during that. So I want to go back to that urinal because it seems to work really well in JFK, but I was at a different restroom and found this urinal. It does have a fly as indicated in the upper left, but when you're actually using the urinal, your vision is more like the one on the lower right. Can you see the fly in that slide? It's really hard to see. It's there, but it's hard to see. And so as you design things, you really do have to try it out and think about it and see how it actually works when the time for using the urinal comes. The design is too vertical and you can't see it. And so there's all kinds of subtleties associated with mistake proofing, and your first try may not be your best. Okay, so I'd like you to think for a minute about what your errors are. What errors have you seen in your environment? What are they? And the next question is, were they skill-based, rule-based, or knowledge-based? So I did quite a bit of work with medical doctors, and some of their errors are rule-based, others are skill-based. But, like a diagnosis oftentimes is more knowledge-based. It's much harder to mistake-proof that. And the next question you should ask yourself about the errors that you have in your environment are, do you have any thoughts about how to fix it? What would make the error more obvious? Or can you create some other failure that's more benign than the error you're experiencing? And finally, if nothing else works, if you can just make it clearer what the right answer is, that's oftentimes enough. And so if you get to read Don Norman's book, The Design of Everyday Things, he has lots of examples of ways to make things simpler and to make the correct actions clearer. Now, for the homework. The homework here is that I'd like you to do something meaningful. I'd like you to eliminate an error and just implement one mistake-proofing device. Once you've done one, the rest are easy. So make one mistake-proofing device where you can eliminate an error And what you'll find is that it will create lots of cost savings. The leverage of mistake proofing is that typically it doesn't cost all that much, and the savings can be profound. Once had a person at Johnson & Johnson who eliminated a $14,000 a year defect using Post-it notes. And so it's amazing what can be done with mistake proofing. I also hope that you will do something based on the last half hour of conversation. And I hope it's something that you'll be proud of. And I hope that you'll do something cool, brew some moonshine, do something with nothing if you can. And so with that, I'm going to say thank you. And Mark, I'm going to turn the time over to you.
All right. Well, John, thank you. I love how that presentation format, mistake proofs against running long, so or the original designers of it and your execution of it here today. So we have a lot of time for Q&A. I will let John catch his breath this time by making a few announcements. So first off, we do these webinars every month. Coming up next month, February 6th, is going to be a webinar presented by Ed Pound from the Operations Science Institute. He's the co-author of the book Factory Physics for Managers, a great book. He's going to be presenting on Apply Operations Science to Accelerate Success Now. So it's going to have a lot to offer for people in manufacturing or healthcare or really any settings who are managing work, managing flow. A lot of great lessons coming up next month from Ed. So you can register for that now or at the end of this session by going to kainexus.com/webinars. Also invite you to check out our webinars on demand library. Well over 100 webinars from the years, all available there. So if you go to kainexus.com/webinars, click on that big button in the right sidebar, it'll take you to that library. Also invite you to check out our blog. You can use the QR code there, or you can simply go to blog.kainexus.com. There are great posts every week about all things continuous improvement. So I hope you will check that out. And also, next, please check out our podcast. You can go kainexus.com/podcast. You can find us anywhere you listen to podcasts. The audio of today's session will be in the podcast feed. Maybe not as helpful as the video, given all the photos. Maybe I'll think about that. But if you are a subscriber to the podcast, you would have heard the preview that John and I did, and there's a lot of other great content in the podcast feed. So please check that out. Okay, so we've got time for Q&A. Please keep using the Q&A button to submit those questions. John, I'm going to start with, this is more of a story than a question, but the timing of you talking about elevator testing or John Otis and the elevator brake, the timing couldn't be any spookier because I live in a tall condo building with elevators, and I'm thankful for the invention of the elevator brake. Well, the city is here inspecting the elevators today, and there was a really loud clunk sound, which we were informed earlier was them testing the elevator brake.
Oh.
So thankfully, that sort of testing and inspection is a real thing, even with all the years that these technologies have been in place. So let me try to turn it into a question, John. Like, what are your thoughts on trying to inspect something that's supposed to be mistake proofed, or how do you know when the mistake proofing is good enough so that inspection might not be needed anymore?
So I think one of the things that your city wisely has done is they understand that mistake proofing requires maintenance.
Mm-hmm.
And that, one of my local companies is a supplier to Honda, and they have next to their machines parts that are painted red that they call Poka-Yoke parts. And what they use those for is they know that those are defects and they know that they're nearly correct. And so they will put them on the machine to see if the sensors that are doing the mistake proofing continue to work properly. And so they will probably do that once a shift just to make sure that everything's working correctly. Now, typically when you're doing mistake proofing, a lot of times it really is disrupting the logic of the process in a way where, the the inspection is occurring as part of the mistake proofing process. And so as long as you're maintaining it and keeping it up, you can probably discontinue other types of inspections because at some level, if you think about it carefully enough, what you're doing is an inspection. Shingo called mistake proofing source inspections.
Mm-hmm.
He's saying if you know cause and effect and you inspect the cause, you hopefully don't need to worry about the effect.
Mm-hmm. So there's a question Amber asked, very similar to something I was already planning on asking you, John. I'm curious what approach you'd recommend for airlines or airplane producers to ensure that different bolts are tightened. I'm sure they already have checklists in place. The little dots are a good start, but maybe hard to see. So, I mean, maybe it's not fair to ask you about the Boeing case specifically, but when it comes to tightening bolts.
Okay, so I'm going to talk about tightening bolts, but I'm not going to infer anything about Boeing. Mm-hmm. They've got experts who are doing their root cause analysis, and I'm sure that they will come to a conclusion, if nothing else, because they're motivated to get those planes back in the air. So, yeah, I too kind of question putting the dot on the end of the bolt. The best mistake proofing that I've seen in terms of torque, and by the way, torque is really difficult. But the best example of that I ever saw was at John Deere, where they used an electronic torque wrench system that was linked to a computer. And so it would not only test the final torque, it would also determine how many times the bolt had been rotated so that you didn't have false torques when the threads on the bolt aren't quite right. It would also count how many different bolts you tightened. And in one case, they knew that they had to tighten 9 bolts. And so they needed the right number of rotations and the right final torque on all 9 of them. Then you took the socket off, put it in a little bin, and in the bin next to it, you pulled out the next size, you put that on your torque wrench, and there was a limit switch in the where the sockets were that would tell the computer that you had changed sizes, and it would then check what you're doing. The challenge with torque is that if you're using pneumatic systems, that if everyone's pulling on their torque gun at the same time, the air pressure goes down, and you get variation. We all know variation's bad, and so. Yeah, torque is hard, and checklists probably are not going to do it. But if you are going to do something like that, the best I've seen is a computerized system to track all of that in minute detail.
Because it seems like a couple different types of mistakes that could happen would be missing a bolt altogether, just skipping over it, versus not tightening it properly. And what I heard you describe, John, sounded like it tries to touch on each of those failure modes.
So the one it's missing, or should I say, the one that airlines already have kind of sorted out, is if you go to engine manufacturing facilities at GE, they give the workers the number of bolts and nuts that they're going to need during the day. If at the end of the day, they've completed all their work and there are nuts or bolts left over, mm-hmm. they will go back through the entire day's production to find out where there should have been one, there's not one.
Right.
And then do corrective action based on that. So that's just kind of a process of elimination approach to making sure that all of the nuts and bolts are used.
Mm-hmm. One of the Poka-Yoke examples that's on display at the Toyota Museum in Nagoya, Japan, is some automation that helps put the correct set number of screws into a worker's hand. So instead of reaching into a bin and having to grab them, it's basically a dispenser with some clever mechanical elements where if it was 6 bolts, you always get 6 bolts. And that seemed to have the dual benefit of also being faster. So I wanted to ask you, John, I mean, I've heard you talk about this before, so this is a leading question, but I think it's an important point, that effective Poka-Yokes don't slow you down. If anything, it can make the work more efficient, faster. Could you share some thoughts on that?
Well, what I'll say about that is that if it slows you down, workers and folks interacting with the process will try and find workarounds. They will try and speed things up. And so the best mistake proofing are mistake proofing devices that make workers faster, makes their life easier and smoother, because those are things you are not going to have to try and convince them to do. And so, yeah, I think a lot of times the very best mistake proofing devices are going to make the worker faster, and they're going to go, oh yeah, this is great. Or it's going to be completely invisible, kind of like the saw stop.
Yeah.
I have students using the saw stop table saw that, if you put your finger in it, it snaps out of the way. I don't have to train them on it. I don't have to tell them it exists. And yet I know that they're protected.
So back to the pneumatic tools, there was kind of a follow-up comment from Amy. One place I worked had a red light that would go on when the compressor dropped below a threshold, signaling manufacturing to stop using pneumatic tools. This ensured the proper torque. Now I'm going to add a comment and maybe then ask for your reaction, John. The insured part, like if a light goes on, like how obvious is that light? How hard is it to not see the light? Is there a way of just somehow cutting off the tools altogether to help mistake proof against somebody missing the mistake proofing light?
Yeah, so I got to tell you, nowadays, the level of mistake proofing that can be done is way better than it ever was. Mistake proofing kind of started in the 60s in Japan, started in the United States in the late 80s. But nowadays, you've got all of these programmable logic controllers that are, they're $10 each. So some of our listeners may be familiar with Arduino or Raspberry Pi, all kinds of different boards that are out there. And so, there are pneumatic valves that are run by Arduino or anything else that you plug up to it. And so you can actually put a lot more logic into pneumatic lines than you used to be able to. And so there's certainly lots of ways to, turn things off if they're not going to work right. And, sometimes I joke that my name for coming up with more benign failures would be benign failure design, which has the very clever acronym of BFD. But I really think that sometimes just finding an error or a failure that's less bad than the error is a great way to go.
Yeah. So a question from Lauren, and there's follow-up questions similar to it. People often struggle with mistake proofing in a service settings, service industries. You sort of touched on this a little bit, John, but could you share some other examples of mistake proofing services processes?
Oh, I could do a whole presentation on that. I'm not sure I have it all right at the top of my head. I do remember seeing a company that was having trouble with quote dates. And so the people who were selling the product over the phone to customers would say, we'll deliver it on thus and such a date. And they would give dates like, December 25th or July 4th, when no one's working. And so one of the things they figured out were just simple job aids around the outside of their computer monitor. They had a calendar of valid ship dates, and it made a big difference. One service that has lots of mistake proofing is medicine. My view is it could use about 100% more, but there's lots of mistake proofing in medicine. So you have people sign their site. So they write their name where the surgeon is supposed to cut. Once they're all veiled, if their signature's not there, you're in the wrong spot. And so, yeah, with services, a lot of it has to do with mistake proofing the customer. There's a great article and book by Chase and Stewart. I actually have the manuscript for that book. Do you know if we have that up and running?
Mistakeproofing.com.
Yeah.
I think so.
So,
Let me double check that maybe while you're
yeah.
answering a different
So
question.
I guess what I would say is, if you're interested on the medical side, please go over to mistakeproofing.com. My full book, which is a government document from AHRQ, Agency for Healthcare Research and Quality, is there, and you can download it for free. And Mark and I have been collaborating on mistakeproofing.com lately. And there's a book by Chase and Stewart that was originally put out by Productivity Press called Failsafing, Designing Errors Out. And that would be a great starting place if you're interested in services.
Yeah, and John, that PDF, free PDF of your book and the Chase and Stewart book, those are both on the page. I put a link to it in the chat. Yeah, John sort of transferred the website over to me. I would admit it's still a work in progress. I'm going to pretty it up over time, but want to keep that website up and running.
And when you go there, understand all of the broken links are mine. None of them are Mark's.
Still working on that. It's okay. But when I think about mistake proofing for services, I mean, I think there's a mindset that applies of, don't blame the customer for making mistakes. Kind of like we might say, don't blame the employee for making a mistake if they're set up to fail. I think that mindset's the starting point, because I hear so many times people say, well, no, okay, we could error proof that, but people just need to be careful. People just need to pay attention, and I just don't think that's helpful.
Yeah, well, have you ever walked out to the garage and not remembered why you went out there? I do that all the time. Yeah. James Reason calls that a loss of activation error. I can't promise you not to make that mistake in the future.
Yeah.
But if I do mistake proofing, that sits there as a design feature, and I don't have to think of it again, and it keeps me from making that mistake. Mm-hmm. And so if customers are making mistakes in the service operation, you should ask yourself why. What is about the process that leads them to think that's the right thing to do, and then start addressing those issues?
Yeah. So a question from Aaron. What do you think about the distinction between device Poka-Yoke and method Poka-Yoke?
If I understand her correctly, a device Poka-Yoke is a Poka-Yoke that's actually on some machine, and that a method Poka-Yoke is something like I use at the airport. I always put when I park, I get on the van to take me to the airport, and they give me a little slip that says which parking spot my car is in, and you have to give it to them on the way back. I always pull that in my wallet, and one of the reasons I do is to make sure I've got my wallet before I leave my car. That would be a method Poka-Yoke, I think, if I'm understanding the question correctly. And I guess my view is that device Poka-Yokes are always better than method or procedural Poka-Yokes. But if you can't get one, you definitely ought to do the other.
Yeah. I mean, to me, a checklist is a form of a method Poka-Yoke, and it depends on how rigorous we are about following the checklist. And I'll admit, the mistake I made earlier by sharing the link to the slides, I thought I was sharing it with everybody. It only went to hosts and panelists, and I only discovered that, I don't know, halfway through the webinar. So that was my mistake. The thing I feel worse about is that's a mistake I've made before. The countermeasure to that is an item on the checklist, and sometimes I skip over things or I get distracted, and I didn't check that. So I repeated a mistake. So yeah, it goes to show checklists are only as good as your willingness to follow them, starting with.
So they have when I was working in industry, they had a word for this. It was called pencil whipping. And you pencil whip your checklist, which means you just go check, 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 and you're done. To the extent that the checklist speeds you up, you will use it. When I pack for a trip, I get a checklist out because I can go so much faster than if I have to mentally dress myself as part of that process. So yeah, checklists are great and they're very effective, provided they're used properly. And there are times it will be used properly. There are times it's not used properly. And Gwandi's book kind of points out which is which.
Yeah.
So that's the Checklist Manifesto by Atul Gawande.
Right. Yeah, that is a great book. One little detail with the Boeing Alaska Airlines flight and the incident when that door plug blew out, it popped open the cockpit door. And my understanding is that there's a panel that's supposed to pop out to help equalize the pressure between the cockpit and the rest of the plane. But the door flew open, and checklists were sucked out of the cockpit and out of the plane. Some of the safety emergency scenario checklists. So the flight crew was literally flying without that, and
oh my goodness,
really deserves a lot of praise for handling a lot of that from memory without the benefit of the checklist. And
the checklists, in some ways, saved the day for the Miracle on the Hudson. So the flight that landed in the Hudson River and everyone lived through it, the co-pilot ran through an unfathomable amount of checklists on the way down. And so it was amazing.
I've heard Captain Sullenberger talk about that. And for one, he credits the co-pilot as being the team. Sullenberger got most of the attention. But Sullenberger talked about how there was no checklist to say, here's how you handle both engines going out due to bird strike when you've taken off from that airport in New York. But they had checklists such as the restart engines checklist, the evaluate where to land checklist. Like the real skill or knowledge or creativity was stitching together the right checklists to help solve that problem.
Yeah, and you don't solve everything all at once. One of the things that hopefully they found out was that flipping the ditch switch that closes all of the orifices of the plane so that it will float longer was not part of the list that he ever got down to. I mean, he did so much so fast, but he never got to the place where he flipped that switch like he should
have. So sometimes with a mistake, I'm not faulting him for that, you still get a good outcome.
Oh yeah,
I'm sure they've updated. Amazing. Yeah,
I heard him speak, and the moral of the story for him was everything worked the way it was supposed to work. The Port Authority had boats out there to rescue people. It really worked remarkably well.
Yeah. Maybe we try to squeeze in a couple more questions here. Lori says, I've heard the word forcing functions in terms of mistake proofing. Can you elaborate on that?
Yeah, forcing function is something that Don Norman used in his book. And if you haven't read it, folks, I recommend it. But a forcing function is simply something that the process doesn't work until you do it correctly. And so when I talk about designing benign failures, that's exactly what I'm talking about. So forcing function is almost like a synonym for that.
Scott asks, do you have any suggestions? Is it possible to convert knowledge-based actions to rule-based actions? Would that make it easier to apply mistake-proofing principles?
I think that's possible, maybe. I think that in medicine, when we see evidence-based practice, that what they're trying to do is figure out what the best plan is and to sort of build rules in. I just don't think you'll ever get there. I think life is too unpredictable. But, zero cost is not possible either, and yet we still try and minimize it as much as possible. So I think the answer is you try as hard as you can to mistake-proof things and to kind of push the boundary on what is rule-based and what is knowledge-based. But knowledge-based is not going away.
So I'm going to combine a couple of questions that were similar. What's some advice for when visual management is ineffective in trying to mistake-proof? And there's a related question about, let's say, a tripping hazard. And if you're walking in a part of the factory, is there a way of indicating that it's dangerous? I'm going to editorialize, build on the question. Something something more effective than a sign saying, please watch your step, because like to me, warning signs are the weakest form of mistake proofing. What would you say?
So I would say stairs are always a challenge, and that any tripping hazard, you probably want to put some kind of stair step over it. And as with any stairs, proper marking, proper visualization, being able to see it well is important. And there was a second half to that question.
Well, just about, I think the first part of it about visual management being effective. And I think sometimes there's variation in what's meant by visual management. Signs, yes, warnings versus, to me, that visual management that helps you see a problem immediately is a form of mistake proofing.
Yeah. So visual management, I think the main thing that needs to happen for good visual management is that you have to have a clean background for it to sit on. If you've got visual management in a visually cluttered environment, it just doesn't work very well. And so I think of what Gwendolyn Galsworth said about that, which was that motion is the shadow of waste. And that as we think about how to create an environment that's visually informative, we probably have to clean things up and eliminate a lot of waste and a lot of excess materials and things like that. And, design is always challenging. And so one of the things I haven't mentioned in my presentation, but I'm really liking in the last couple of years, is this whole concept of design thinking. Mm-hmm. And I think it links very nicely to lean and to and is useful in that aspect.
Yeah, there was a comment here before we wrap up by Monica after you showed the device that inspired the seat elevator. Monica called this analogous inspiration. It's one of her favorite design thinking strategies.
Oh yeah, absolutely. So yeah, keep your eyelids open and look around, because a lot of times you will see things that you can then use elsewhere.
Yeah. And I think, the other homework that I'm going to pose, and by the way, if anyone implements a mistake proofing example that you're willing and able to share, it would be great to do a blog post as a follow-up. You can email me, Mark at KaiNexus.com would be a great email address to use. But maybe different homework is just looking around, whether it's at the gas station, at a quick service sandwich shop, like look for different elements of mistake proofing that you interact with as a customer or a user. And, or sometimes you might notice the lack of mistake proofing, and that can be a helpful exercise, I think, of building up that mental catalog, as John was helping us do today with lots of different examples. That doesn't tell us how to error proof that exact situation, but I think being exposed to more and more examples helps us be creative when it comes to our situations. John, I'll let you have the last word on that.
And so I would add to that mistake proofing already exists in whatever environment you're working in, and you can just go around and identify those. In some cases, I think in factories, if you had little Poka-Yoke stickers and you just stuck them on existing Poka-Yoke devices, you'd be surprised how many there are.
Yeah.
Thanks for having me, Mark.
Yeah, well, John, thank you for doing this. So again, want to thank our presenter, John Grout. Really invite you to come to mistakeproofing.com, read his free book about mistake proofing in healthcare, and the other book that he mentioned. You can also get a free chapter download of my book, The Mistakes That Make Us, that again cites and mentions John. So I want to thank everyone for attending, and we'll see you next month for the webinar on February 6th. John, thanks so much.